Scalability theory. Scalability means expansion, means you increase the number of users you support, you enhance your services, expand it, make it larger scale, right? Scalability. In this section, we will be designing a generic web server, which will be handling a large number of requests. You can imagine it as some sort of website like Facebook in which large number of users are accessing it. So we have the clients, the users here, and we have a web server, and we have a database connected to the web server. So basically vertical scaling, like vertical expansion, is enhancing the computer ability, increase the memory, increase the like stuff. Horizontal, it means we add another server, we add another computer, we add more computers. And load balancer will be covered. Let's go through each one of these. Vertical scaling. Vertical scaling means that you scale by adding more resources, higher speed CPU, more RAM, etc. to expand to existing computers. So it's vertically go up, right? So you make it more powerful. Vertical scaling has its own limit, and it can help you to handle more load, but until its limit is reached, then we have to go for horizontal scaling. So it has a limit. Vertical scaling, you reach the limit where you made it the maximum, right? In the horizontal scaling, you add more computers. Horizontal scaling means that you scale by adding more machines to your pool of resources. Machines mean computers or servers or mainframes, right? Distribute the request by distributing the request among more than one web server. So you distribute your request. In doing this, we need to have a load balancer that will be covered in the next section, which will distribute the request among servers. It balances the load, right? And it does that using several techniques that we'll go through them now, right? All right, load balancer, it's an application layer. Load balancer has to decide which server should serve the next request. So distributing the load can be made using different strategies. So the load balancer balances the load, so it distributes the load, but it follows different strategies. The first one is round robin. The first strategy to be followed is round robin. So it just keeps distributing according to a cycle, right? Round robin is the way of distributing requests in a sequential fashion. This request is sent to server 1, the next request sent to the next server, the next request sent to the next server, and so on. Till we reach the end of the server list. Then when we reach the end, it is sent again to server 1, and we keep going in a circle. Round robin has a problem that a server which is already busy may get another request. Round robin also has a problem with sticky sessions. We want that a request to be sent to the same server next time, right? So sometimes we would like to deal with only one server. And the second approach is to select the server correspond to the hash value of the data. Find the hash value of the data, mod the hash value by the number of servers, assign the job to a machine whose value we got after mod. Tick session problem is already solved in hash value approach. However, the problem of uneven load distribution is there. It's not equal distribution. The load is not equal. A load is overwhelmed, a server is overwhelmed, the other servers are not. So we still have that problem. There is a possible that we have more load sent to a server which is already busy. It's already busy, and we keep sending a load to it. So the third strategy, so the first one was the round robin in sequential form. The second using a hash code. So if there is a request that needs to always dedicated to send to a specific server, it's solved here. And the third one, maybe the load balancer know how much load each server has or how busy each server is. Moreover, we'll send the next request to the least busy server. So the third approach is you send the load to the free server. So if you have a task that is stuck or hanged, you don't keep sending load to that server. You just deal with the free ones. If you have a crash server, you deal with the free ones, right? Just like that. And the fourth strategy, server can be a specialized one serving image, some serving videos, and some serving other data. So it depends on the type of request you send to dedicated server. This is another type, another strategy. So we have 4 different strategies used by load balancers, right? Here's the client, here's the load balancer, and here are the servers. A problem of load balancing. Consider a customer who had selected some items in his buy cart on Amazon. When he selects another item, it should be added to the same cart. So it should be sent to the same server. All right. Or maybe through different server to the same database. I'm not sure. But according to this book, it should be sent to the same server. Also, the user profile, which is saved in one server. If the user request reaches the other server, his profile will be empty. This is also not a good idea. This problem can be solved by making the load balancer decide the particular user request would always go to the same server. The user profile and card details should be saved in some database, right? Stick session. Same sessions should land to the same server. How to get this done? The first approach is that we store the IP address returned by load balancing into a cookie and then use this IP address in the subsequent request. However, this reveals the IP address, so this is a security weakness, right? This is not a good idea that you save the IP address in a cookie, because this reveals the IP address of the server to the world, and we do not want that, because it's a security breach. They might attack the server, and this is a security hole, or they call it a vulnerability, right? Therefore, another solution, so this solution has a weakness, security weakness. Therefore, another solution is that we use some session ID, that a number that the load balancer knows that belongs to which server. By this, so we use a session ID. By this, we are preventing our servers being exposed to the outer world and prevented from being attacked, right? So we went through the load balancer on the application layer in the previous section. This is called load balancer application layer. Do we have load balancer on lower layers? Because the application layer in the ISO model, it's the top one. We have load balancer on the database layer. That's in the database system. The most basic approach is round robin. Data is distributed in circular fashion. Same like the first approach in the previous section is repeated here, but this time on the database layer. First data go to the first database, second will go to the second database, and so on. Each database server has an equal load. However, it has disadvantage that the data lookup is complex and need large lookup table. So it has a disadvantage. Another approach is to divide the data in such a way that all data will go to the first machine until it reaches its maximum capacity. When maximum capacity is reached, then the data goes to the second machine and so on. So you have database servers, you fill the first, then go to fill the second, then go fill the third, and so on. This approach has an advantage that only the required number of machines is used. However, it has a disadvantage that the data lookup is complex and need a large lookup table. The third one, another approach is to select database corresponds to the hash value of data, find the hash value of data, mod the hash value by the number of databases. The data are then stored in the database value we got from the modulus. All right. For has for has what's that for has a value approach. I think this is a typo. All right, for the value approach we do not require any lookup table. And this approach we do not for hash. I think for hash value. All right, this hash value, I think it should be like this here. For hash value approach, because this is the hash value approach, we do not require any lookup table. We can find database which is storing the data by finding the hash value. However, the problem of uneven distribution of data is there. There is a possible to have more data sent to a database which has already reached its maximum capacity. In this case, we need to find a better load balancing key or split the data from the database into a number of databases. All right. And then the next strategy in the hash value based distribution of data, there is no relation between the data that is stored in a particular database. Information about the data can be used to make the database accessible faster. For example, in social networking like Facebook, if someone who lives in India is more likely to have friends from India, and someone who lives in US is more likely to have friends in US. So you have it like clusters, right? More likely. Perhaps location aware approach 4, maybe depending on the location and this type. Perhaps location aware approach 4 and the hash value based approach 3. Distribution of data may be the best approach to keep the data so that it can take advantages of both approaches. Country code and user ID can be used to get the location of the database. Redundancy. Let's isolate this in a separate video. All right.